How to create an artificial intelligence. So far I have explained what is AI and tried to show things to keep in mind while training it. And now I want to talk about where to click to have a working AI. It's easy really. All you need to do is to install Python, then code an AI, and then it's done. Joke aside, those simple steps can become as complicated as we want them to be. There are, for instance, tons of different Python implementations. And to write the code, there are easy solutions for people like us, while more courageous people would use Vim or Visual Studio. So let's rewind a bit. Install Kate and CondaForge so that you can call it from a terminal. That's a bit old-fashioned like me, but it's a solid starting point, and you can change it later if you don't like it. Here is where you can get CondaForge, and here is where you can get Kate. And once everything is set up, it could look a bit like this, with Kate on the left and the terminal on the right. Now that the presentations are done, let's check that Python works. In the terminal, I call IPython. It's a Python interpreter with colors and hints that make it easier for me to code. Everything works. Let's quit IPython, clear the terminal and do the same in Kate. Look, as soon as I save the file, Kate understands it's a Python source code and add colors and hints that make it easier for me to code. And let's make the text bigger also. We can now execute the code in the terminal. Everything works. Let's proceed to exuberant exultation. Yay! Now let's get down to coding char RNN as a poor man's ChatGPT. It's a good habit to write in the program what the program is and what it is doing. A first step would be to load the alphabet. All letters of the alphabet are printable. Let's load everything that is printable. And check a letter, for example the 11th. Before trying it in the terminal, we need to import the string library that contains printable letters. Everything keeps on working. The 11th letter is B. Let's go back to more important questions. Here is our prompt. We need to transform this prompt first into numbers, then into one-hot encoded vectors. We can do it like so. First we create an empty list that will contain the numbers. Then for each letter in our prompt, we find its index in the list of all printable letters. That is its position. Then we append the index to the list of numbers. We can print out the results to see what our prompt becomes. Here, impossible to understand already. It starts with 39. What is 39? Capital D. Looks good. This letter to number conversion is likely to be something we do a lot. Therefore, let me put it in a function real quick. It's really a matter of copy-paste. But to be on the safe side, let's try it on our prompt. Yep, still works. Now to the one-hot encoding. There is a neat trick with the identity matrix. Let me show you. The identity matrix is a square matrix that has ones on its diagonal. So, if I pick a specific line or column, it will have a 1 and all the other numbers will be zeros. That's a one-hot vector. Yay! But instead of doing that, we will use PyTorch. That will be useful later when training the network. PyTorch is a function that can transform a list of numbers into a one-hot encoded vector. But for that the list of numbers need to be a so-called long tensor. That's another way of representing the list of number into the computer's memory. Here I make a very small list of number to show how it works. I get a huge warning because I'm running an old version of PyTorch with a new version of NumPy. But in the end, I obtain my one-hot encoded vector. Let me make a function of that in our program. Oh look, I have added weird things. Float and unsqueeze 0. I have done that because this is not my first neural network. The float will help me later when computing the loss. And the unsqueeze adds a dimension that will help me reference them in a batch. That is to demonstrate that looking at video helps understanding how it's done. But doing it yourself actually helps picking up some tricks. While telling that, you have seen me transform our prompt and look at its dimension. 1 is the batch size. We have the entire prompt in the batch. 36 is the length of the prompt. And 100 is the size of the one-hot encoded vectors. Well, if we have come to that, let's do a neural network. Let me define some parameters. The input size is 100, the size of the one-hot vector. The hidden size, a number of layers, are things I know I need because I'm programming char or NN, and I have done some reading about it. Let's mention as well we want to have the calculation perform on my GPU that the first dimension is the batch size and we want to train the LSTM. No error in defining the network. Yay! We don't know if it works, but we have the spelling right. Let's try to send our prompt through the LSTM and just define a hidden state because I read it in the PyTorch documentation. Oh no, an error. Forgot to close the parenthesis. Another error. Yes, the tensor containing our prompt needs to be on the GPU as well. What now? Oh yes, let's send the hidden state to the GPU also. Now it works. Well, that was cumbersome. I will now put the entire network into a class. The effect of that will be to separate two problems, how to define the neural network and how to use it. And I will pretend this will be less cumbersome. The definition will happen in the class, and its use will happen when I will call the class. As you see, it's quite a fight to have everything written as it should be in Python. And don't get me started about the song. I happen to enjoy music, so I can't listen to the song. Not to mention that no two people who claim to code as per the song actually code alike. Anyways, once I have all the parentheses, comma, colon, hidden state and device problem sorted, it works again. I can then add inside the neural network other things I read about in char or NN, namely the fully connected layer and the activation. Then I can modify the propagation of the tensor through the layers in the forward function. And finally, I can send the tensor through the network and obtain a result. Look how beautiful it is. I doubt it even means something because we are yet to train the network. For that we will need an optimizer. Adam is always a good first choice. Afterwards, if you are chasing a paper, go to another one, but start with Adam. And a loss. Let's start with the cross entropy loss. Oh, I forgot hyperparameters, a learning rate, and we will start by training on 2 epochs. That should not be too long. It's now a matter of loading the training set. I use the King James Version of the Bible, but any text would do. Thanks to the functions we wrote earlier, transforming the training set into one-hot vectors is a breeze. And we can now jump to the training itself. It's a bit of a non-trivial thing in itself, so I'll cut this video short here and make another one about that. This is the end of this video. Thanks for watching. See you next time. Or stay for a message from the sponsor of this video. Me, I'm the sponsor of this video. Stay tuned for my next video on how to train and check the network and how to use it to generate sequences of letters. That was an advertisement for my next video. Look at it. Bye now.